All right, we are at our final piece of information that we have for the course. We're going to talk about scripting for a minute. So all throughout the course, we've learned a lot of different commands. But one thing that we can do to make things a little nicer is we can actually put a series of commands together so that they'll run sequentially, and we'll call that a script. So we're going to just talk about Bash, but theoretically this could be any interpreted language, like Python, for example. And it will just, the idea behind it is we're using that to automate repetitive tasks. The file contains just a series of shell commands. So how do we do this? We'll start with a plain text file. So you'll use Vim or Emacs. The first line should always be this, they call it the shebang down here. The hashtag !bin/bash. And this tells the interpreter or the shell what interpreter it should use in order to process the following commands. So, and this says we're going to use bash to process the following commands. If we were writing a Python script, we would use like /user/bin/python with the hashtag and the exclamation in the beginning. Okay, after we create the file, we need to give it execute permissions. So we'll do something like chmod +x or chmod 755. Somehow give it an execute permission, probably for the user. You got to be careful with permissions again. You probably don't want this might not want it available for world executable. When the script is working the way you want, probably want to make it available via your path environment variable. Now, I'll show you that in the demo, but basically if we make it available in this environment variable, then we can execute that command wherever we are at on our system. It doesn't matter what path we are currently navigated to in order to execute the command. And if we ever put other commands inside of our bash script, like let's say I'm having my shell script, I'm having it do an ls command or who or I don't know, cat or echo or something like that. The best practice is to put the full path to those commands, like bin/ls. You can sometimes get away without it, and I do that a lot, but the best practice is to put the full path to those commands. Here's a very simple example script. All it does is we have our shebang here up at the top, tells the interpreter or the shell that it should use the bash interpreter to process the following commands. We can do comments with a hashtag at the beginning, and this is just as an echo statement. And then I would go chmod, make it executable, and I could run it, and it would just print out hello world to the screen. Not that exciting because it only does one line of stuff. So I'll show you that when we do examples. But to run our script, back to the path variable again. All of our commands are stored as files. It is our path variable that determines the directories that the computer looks in for commands that we type. To run a command, a script file that isn't in one of our path directories, we can add our desired directory to the path variable, add our script to an existing command path, type the full absolute path to our script, or simply begin our command with a /. It says look for our command in the current directory. So on that previous command, if I had named it myscript.sh and I was in that directory and I chmoded it to be executable, I could just do a /myscript.sh to run the script. Okay, so I'll do some of those when I get to the example section again, but let's talk about just a couple other things. Just like any programming language, Bash, scripting language, allows us to create variables. A variable is just a placeholder in a script for a value that will be determined when the script runs. Variables values can be passed as parameters to a script, generated internally to a script, or extracted from a script's environment. We won't do all those. Our goal here is not to become expert script writers, just getting a little flavor or taste of scripts. So here's an example of variables. Once again, here's my shebang at the top. These other two lines are comments, and this is the only line that actually does anything. this says we will run this command with ./foo.sh. We can pass in 2 arguments, and now inside of my script they will be available as $1 and $2. Variables within the script, we can always use the equal sign or assignment operator. So I could say the variable ping is equal to this. We could use the read statement. I could prompt the user for something, saying, hey, enter your name, and then we'll read it into a variable called name. These variables can always then be referenced with a $sign in front of them. Finally, we can take the results of a command and store it to a variable like follows. This will say, if we put a $sign in the parentheses, this will actually run that command ls-l foo.txt. Then it will take the result of that command and store it in the variable d. Or, actually this one didn't print out very well because it really needs backticks around that. That's another way of doing it. The backticks can be substituted instead of this $sign parenthesis, but that's the preferred way of doing it, is the $sign parenthesis. Okay. Variable names can be surrounded by optional curly braces when expanding. So let's say I set a variable called file name, and it's equal to this string, my file. Then I could say touch $sign file name, create that file for us. So if I try to do this, let's say I want to rename it from my file to my file 1, we could say, hey, go grab the contents of file name, which is my file. So move my file to my file 1. It doesn't work because this thinks, hey, I'm looking for a variable called file name 1. So if we're doing something like that, we can actually say, hey, look for the variable file name and then put a 1 at the end. This is a little bit more picky stuff. Once again, we're not going to be experts, but just some things. Okay, conditional expressions. We do if statement to test if something is true or false. Here's one example of doing that. So we can say, see if this file is found. Here's my if test. Test goes inside of these square brackets. We always have the word then. So if that's true, then do this. This one didn't indent right, but the end of our if statement, we should always have an fi. That closes our if statement. There's another example. So we say if our test expression is inside of square brackets. We always have the word then. Then we could have put some commands in there that we want to do. We could have an else if we want to. We could have some other commands here, and then we could end our if statement. We can do some comparison operators. Once again, I'm not going to spend a ton of time here, but we can test integers for equality. We can test strings to see if they're equal to one another by using the double equal sign. If you look on the link in our text that we're using, there are some expressions there. So here's some other comparison operators. We're going to test if they're not equal to one another, if they're less than, greater than, so forth and so on. So there are references to that there. Loops. I want to do something more than once. Here's an example of a for loop. This one will do it 10 times. You could copy and paste this in to a file, chmod it, make an executable, and run it. So this says, hey, create a sequence of 10 numbers, loop through each of those numbers, and so this would create file 1, file 2. So basically we're saying take that number 1, copy it into a variable called I, and then the first time we go through the loop, we'll call that file1.txt and we'll create it. Next time we'll go to number 2, copy it into I, create file 2. So this will create 10 files really fast. So that was kind of a very high-level overview, some things we can do with scripting, and my next video will show you some examples.